Hello students, welcome again to Solochem Lab. There's a problem on the board. It's a 2021 UTME problem. We are given two reactants, X and Y. The two reactants combine to give us one product called Z. And then we have delta H equals positive. That means the forward reaction is endothermic. And we are told if the reaction above takes place at room temperature, the delta G will be, some options are given. First of all, what is room temperature? Room temperature means how cold or how hot normal room is. And according to chemistry literature, room temperature equals 25 degrees Celsius. And 25 degrees Celsius, as you see on the board here, let's change it to absolute temperature. That is Kelvin. We will add 273 to 25, and then we're going to have 298 Kelvin. That is, assuming this reaction is carried out at 298 Kelvin, what will happen to delta G? First of all, what does G mean? In chemistry, in physical chemistry, G refers to what we call Gibbs free energy. Gibbs free energy. Gibbs free energy is the energy that is available in a chemical system to do work. The energy that is available in a chemical system to do work. That's what Gibbs free energy is. And again, there are other terms you need to understand, which is H. The term H refers to the enthalpy. That is the heat content of a reactant or a product in a reaction. And so delta H means the change in heat content of the reactant and product. That is, delta H equals the heat content of product minus the heat content of reactant. Another thing you need to understand before you can attempt this question is what we call entropy. The symbol is letter S, entropy. The entropy of a matter is the degree of randomness or disorder in the particles of that matter. The degree of randomness or disorder in the particles of that matter. That's what we call entropy. And we use the letter S to represent it. So when you see delta S, like here, delta S, it means change in entropy. Particles in a gas, do they move randomly or do they move gently, slowly? They move randomly, hitting one another and also hitting the walls of their container, exerting gas pressure. Therefore, the entropy of gaseous particles is usually very high, while the entropy of particles in solid form is very low. Do you understand? Now look at this reaction on the board. Two species are bonded to form one species. What happens to the entropy change, the delta S? What do you think happens to it when two species are bonded to form one? Is the delta S going to be positive, that is high, or is it going to be negative, that's low? When one particle in gaseous form is bonded with another particle in gaseous form to give us just one species in gaseous form, the degree of randomness will drop because there's a bond that is forming between them. Do you understand? Now, if the degree of randomness will drop, it means delta S, which is equal to S, the entropy of product, minus the entropy of reactant. The entropy of the product, which we say here is here, has dropped. It's going to be small. Now, the entropy of the reactant will be higher. When you take away the entropy of the reactant from the entropy of the product, you are going to get a negative value. So delta S here is expected to be negative. Do you know why we need that information? Because we are going to come to this equation here. delta G, that is change in Gibbs free energy, is equal to change in heat content, change in enthalpy, minus temperature multiplied by change in entropy. And we've been able to agree that the change in entropy for this reaction here is negative. It's negative because two species are bonded to give us one. That means the degree of randomness is going to drop because of that bond that forms between them. Do you understand? And when the degree of randomness becomes smaller in the product, if you now go ahead to get delta S, you are going to have a negative value because the entropy of the product is going to be smaller than the entropy of the reactants put together. Do you understand? And so you are going to get a negative value. Okay. So when you take this negative value and place it here, right inside this bracket, minus times minus, what is it going to give to us? Positive. And when you add it to the positive value of this delta H, which is what it gave us here, you are going to see that the delta G, that is Gibbs free energy, change in Gibbs free energy, is going to be positive. And that is option C that is given to us here. Do you understand? Do you still have any other question? When the delta G of a reaction is positive, what is the meaning? What's the interpretation we can give? Look at this information here. Delta G is greater than 0. That means the delta G is positive. What does it mean? It means that that reaction is non-spontaneous. That reaction at that condition cannot go on its own without changing other factors, without other factors being changed. It is non-spontaneous. It is not feasible when delta G is positive, as in this case described here. What if the delta G is less than 0? That means delta G is negative. If delta G is negative, it means the reaction is spontaneous or feasible. That reaction can go on its own. The reaction can proceed on its own at the given condition. You don't need to adjust any other condition. But if delta G equals 0, it means the reaction is at equilibrium. Do you understand? So, do you have any question? If you have any questions still, remember, feel free to drop the question in the comment area of this video. And in our subsequent classes, we'll look at those questions. Thank you.